Hi everyone, this is Anurag, one of the co-founders at TrueFoundry. At TrueFoundry, we have been enabling companies to kind of deploy machine learning as well as large language models to production, including training them in an efficient manner. And we have been talking to a lot of leaders who have built really good ML platforms. And today we have with us Katrina. Katrina Ni is a senior ML engineer as well as a lead member of the technical staff at Slack. We all know Slack. Slack is one of the biggest conversational platforms for organizations and companies. So yes, he has been leading the ML team there. Worked with the Recommend API, spam detection across product functionalities, and prior to that, he was a software engineer in the Tableau Explain data team, where again he worked on a number of products. It's great to have you here, Katrina. Look forward to the to speaking with you. Maybe if you want to add something to your introduction, it will be great to kind of hear about your journey.
Yeah, the introduction sounds great. Hi, Anurag. Glad to be here. Yeah, looking forward to our chat as well.
Perfect. Great. So, Katrina, maybe one thing that we love to start with is some of the use cases that ML and Gen AI powers at Slack. You can talk about some that you have kind of, you have been catering to before, as well as with the coming of LLMs, special use cases that are being powered. We love to hear start there. And how does it impact the user journey?
Yeah, like our team, like before, like the LLM age, I guess our team is mainly behind, as you mentioned, the recommend API, where we surface recommendations across the product function teams. Like some kind of example, maybe uh, kind of what we are working on, like the recent one, maybe when users join like a team or like join a team, they may know they may feel confused and don't know which channel or which people to connect with. So one possible use case is like based on like the user's inviters or like other kind of relationships we got from data, we can suggest like relevant channels or like users that the user can connect to. So it's really like a lot of those use cases where like we kind of ease like the user experience, make it more smooth, I guess. um and Yeah, so like Slack is not like the business model is not like it's not based on recommendations. So so it's not like a huge something like that we built, like a recommend agent and engine that we like sophisticated, really sophisticated recommend engine that we build. What we want build is like really something that can be integrated really easily into like the all sides of the product. And yeah, spam detection, malware, like just also like maybe scanning malware links is also like two kind of small two kind of smaller feature that our team own. Yeah, after the LMH, I would say like it's a bit more, still like a bit more uncertain, and then it's like just like a lot of changes is going on, but our team will still be responsible for like supporting, like if there's any infrastructure requirement, we will definitely be the team to supporting like hosting, like for example hosting our in-house LLM models, and then any like ad hoc support. For example, I'm kind of helping with the prompt like tuning at the moment, so any ad hoc support to the product team is like our main focus at the moment, for
Right.
sure. Yeah.
Understood. So we'll definitely dive into it later. Like we'll talk about Slack GPT and others. Maybe to start with, in terms of the infrastructure, it would be great to know the journey of the infrastructure evolution at Slack, say over the last few years, especially around ML. And at a high level, how does the infrastructure look like? And we'll then dive into the recommend API and other things later on post this. What is the
Yeah,
infrastructure built on? Where do you kind of do your training and so on? So at a high level, it will be great to touch base on that, and then we'll dive deep.
like what, just kind of talking about infrastructure, right? Yeah, so like our team, you will see like our team actually, like we have a lot of dependencies on like Slack's other teams, like huge dependency on data engineering teams where we like Slack has a really nice data warehouse and then dashboard, and then like setting up Airflow to, like do job scheduling, and then just like big data processing. Like we rely on them a lot. And then also like the infrastructure, also like microservice speaking, there's like a cloud team in Slack. So
Mhm.
there is like a kind of some framework which is built upon Kubernetes, and that makes it really easy to just spring up a microservice. Uh,
Right.
just super easy. Like you just like a YAML file is pretty much like, and other tweaks and stuff. And then also like the feature store wise, you will see like we actually don't use any commercialized like any open source, like, oh, like like feature store people know of. We have our own, like it's I think it's like when it's developed when feature store is not a thing yet, so we have our own feature store like hosted internally. So like we do have like everything that's like
Right.
you may know like some open source or some company behind it, but we kind of like, I feel like we do a lot of stuff on our own. Yeah, so it's like a kind of
Got
interesting thing that I noticed when I joined Slack. Yeah.
Awesome. And you have built your entire infrastructure on top of Kubernetes. Like any particular reason for choosing Kubernetes as the base layer, Katrina, on top of which everything was running? Like,
I think it's really like, one is like, I guess it's Kubernetes, and then and then the second is like there is just like internally in Slack, there's a movement to just to use more like Kubernetes cluster, because like there is another team that built another layer on it, which makes it easy to use. Like there's just a movement to use that instead of EC2 cluster or like whatever. Yeah, so like we just kind of yeah, and we think it's like it's I think we used to, like before I joined, we do used to have like actual like EC2 cluster to like train
um,
ML jobs, but then yeah, then like like we kind of moved to like Kubernetes, and then adapted like the trend to just like in general in the company to use Kubernetes.
Uh, that's great to know. Like we have been talking to a lot of companies, and we ourselves build our stack on top of Kubernetes, and we are finding a huge movement for
Mm,
companies trying to move their stack from EC2 and the SageMakers of the world to an actual Kubernetes-based stack that can scale well and gives them the flexibility. But at the same time, as you said, like it's hard to use, so there needs to be like an orchestration to make it easier.
yeah,
So it's good to know that your team.
yeah.
Any specific parts where you are aware of, where you all have to kind of do things to kind of make it easy to use, like the Kubernetes there, or that was done by some other team?
Kubernetes. Uh, yeah, like there's like a totally different team, like that's kind of building a layer upon Kubernetes. So like, and also like connect to a lot of like Slack's internal services. Like we use console, or like for networking, like like those kind of thing. I'm actually not that familiar with cloud
Okay.
infrastructure,
Uh,
but
yeah.
Slack
Yeah.
has like all internal like stuff going on, right? So it's really like a layer which builds on Kubernetes but connect to like Slack's other stuff. So like once you write a YAML, you will have like a service discovery. You will have like a lot of like metrics, like dashboard Prometheus metrics, like coming along together with it. So like it's really a lot of work from the other team that make it
Understood.
easy. Although
Understood.
like I would say it's still not really very easy for other team, like a lot of like it's like for us, because it's easy because it's our microservice is mostly stateless. So like it's just, in this case it's really just like it's kind of we pass some kind of data, and then like the prediction comes out. But for other team which is like, or other features which heavily involved like databases, like which is stateful, it's really hard to still like transition to like properly, I guess. um
Okay. I understood. I understand the challenges that you mentioned. Let's dive into the recommend API that was built, and then you came over and you actually improved it. And there's a blog that you have written. Maybe dive a little bit into the journey of what the recommend API was. What has it? how has it evolved into, and maybe we start
Yeah, the recommend API that I know of is like kind of like before I joined, so there's some kind of um like just a lot of effort to make this embedding and then fetching kind of mechanism work. So like we like there's a lot of work processing like Slack's huge amounts of data, and then find out like how users interact with each other or channels, and then also like some kind of based on messages, like just a lot of processing to generate the embedding. So we do have like a kind of embedding service there, which is mostly based on user activities, but less a little bit. There is like one based on messages, but it's really like more or less. I think it's a word count. Kind of, it's like maybe 5 years ago. Like embedding is like I don't think it's like everyone has adapted yet. So we have like a infrastructure for that, and then we use that to fetch like similar users or channels. But afterwards, like we built that, we like I think my this is my take, and I joined after like midway. So after that, there's some change in the team and the leadership. So like the team is thinking about how we can utilize this embedding and fetching mechanism to help like just build a better Slack product. So that's when I think people started to think about, yeah, recommendation. Like there are like a lot of places you can think of in Slack, like small places, but a lot of places you can think of just to recommend users of channels or like users to other users, like just make user easy to like have a better user experience. So they kind of started with this recommend API where like just like it started from like we wanted to build something that can be integrated with to different places, and then um, so and we also wanted to have this workflow like the flows of fetcher, which we will be utilizing that embedding kind of uh, mechanism that I mentioned, and then like just and then you also utilize the feature store inside of Slack, like built inside of Slack to kind of expand the data with a lot of features, and then doing some filter and then scoring, and then that kind of workflow. So yeah, so that's where I think it came from.
Great, Katrina. Like, thanks for sharing about the recommend API and also about its evolution and how it kind of powers some of the workflows internally. I would love to kind of maybe dive into a little bit more detail of the model training pipeline for the recommend API overall, and the overall architecture there. Um,
Yeah, so I guess like the training pipeline is like really like kind of we have like a cluster kind of that's doing like we just send a Kubernetes job to the cluster, and then it can just train like so for like so just kind of start from like a little bit beginning like like I kind of mentioned we have this hierarchy of like corpus, which is like either channel or user mostly at the moment, and then source is like use different use cases like this is for daily digest, and this is for like composer, and then this is for channel browser. So we have different use cases under like each source. So for each source we do have like train various of like models. Like we always try out like kind of first largest regression, and then kind of move to XGBoost, or like sometimes light GBoost, like try out different kind of flavor, or like different they was like trained on different data or like different parameters. So we for each use cases we do train like various models, and then this is kind of all set up based on this hierarchy. So it's like the training happens in Airflow, and then it's actually like the Airflow is pretty straightforward. Like it like we got the data, and then we just in the Airflow we sprung up like a Kubernetes job to do the training, and then during the training we log the offline metrics, or log some model parameters, like stuff that we can monitor ourselves in the future in case we wanted to look back. And yeah, it's actually pretty straightforward. Yeah, it's really like the process is really also again it's made it to be really easy to just add new sources or new models to train. It's like we kind of designed it to make it really easy. It's like maybe one line, two lines of code change to just add a new model to train for each source. Yeah.
Got it. And you mentioned that you all use Airflow for the pipelines. Any particular reason why you all use Airflow versus say the other solutions out there in the market, say a Kubeflow or a Metaflow, and any drawbacks that you have seen of using the Airflow system in training, and maybe the advantages that will be great for the users to touch base
Yeah,
on.
definitely Airflow. Like the reason we use it is really like I mentioned, we depend a lot on data where like our data engineering team,
Yeah,
the Airflow is what they set up to use. And then I think at the time Airflow is the major player. Kubeflow
got
is not there yet. So like I feel like maybe at the time like Lingui or like there's a like they I think they compare maybe can produce some comparison with Airflow and others, but Airflow is like a better choice at that time. It's just yeah. So that's why we use it. Honestly, I haven't tried other orchestration kind of framework, but yeah, Airflow. I think it's usable. Like, but we do encounter a lot of times where like the DAG, like yeah, like we like during on-call. I would say like it's either like big data processing and then Spark or like Airflow. So like during our on-call, like our major thing is really like, oh, this DAG, like usually it's data processing DAG or like this task failed. So like we just need to spend a lot of time to figure out why. So, but I don't think it's like internally like due to Airflow. I think
it.
yeah, I'm fine with it to
Okay.
be honest.
Understood. And then you mentioned about this hierarchical concept, where there is a source and then the channels to which
Mm.
data is coming. And so, at any point, like just for users, like if you can give a sense of, given the number of people in the machine learning team, how many such models would be getting trained at any point in time in the overall Slack system?
Oh, yeah. I guess, yeah, if you look at the ML training DAG, it does look a bit crazy for each source. We have like a lot of like train a lot of model for each model. We also have tasks to like write like either like do anomaly detection or write some like metrics or like do some explainability report. So like the DAG is actually pretty crazy, but I would say we train it must be like more than 20 models that we train like
Okay,
at this like but it's like easy to set up, so it's really just eating up the resources a bit, but like it's really easy to set up once you have like the framework.
got
It's
it.
like 20 30 models that we train at the same time, but then we kind of it's not all of them are deployed, of course. We
Got
pick
it.
yeah.
Got it. And you had earlier mentioned about the feature engineering layer, like and that you all have built it yourself. Like how is it like a separate online offline feature store? Is it the same feature store that powers both, the production and the training? How do you kind of ensure there's no skew across the features in online and offline training? Like, would love to hear a little bit on that.
Yeah, the way we work is actually, I think it's a bit different, like like from what I read, like how you use feature store is like we actually log all the data like online, like the data we train is like the data we got online. So
Got
so when we like we fetch the data from the feature store, right, and then we just log it.
it. Okay.
It's usually like user interaction data. Most often we don't log all the data, we don't log sensitive data at all, but it's
Great.
okay for us to log user interaction data, so we just log it. So that becomes our training data. So yeah, so I don't really see like yeah, in this way it's actually we are logging a lot of data for sure, but it's like we have less of issue of like online data is like different from offline data.
Got it. Understood. And then suppose this training is being done for different models for whatever source they are coming from, and then how what is the process? And you log these models. What is the process of then moving these models to production? What is the validation that is happening? I would love to hear about the framework in between and the overall workflow there.
Yeah, exactly. So I think it's in general, it's nothing different from maybe what other companies did. Like we first if it's like a new use cases, a new use case, I would say like we will check because we also are logging the offline metrics, and then we build dashboards to compare different models. What's their AOC, like just a lot of metrics, like for classification or ranking. We just compare their offline metrics to see which model might be better. But usually, like it's because it's really easy to run A/B testing. So if like the metrics look similar or like it doesn't differ, because sometimes offline metrics doesn't reflect in online metrics. So we always try even if like the offline metrics is like this model, like Light GPT looks a bit better, and then but we always just maybe try to run like even like a very small change. We always run like A/B testing to make sure like the online metrics is reflected. We always just go to the model which has a better online metrics. Yeah, like so really just A/B testing, and then we decide like which model we wanted to pick in the end.
Okay, and do you use your own internal A/B testing framework? Or?
Yeah, we do have like internal A/B testing framework as well, and it's not just used by us; it's used by like product teams. Whenever they launch a feature, like they have like very like a lot of like data scientists kind of design a lot of like the business metrics, and then
Okay.
like so yeah, it's used heavily inside of Slack.
Got it. Understood. Given the huge scale that you all run at, I was wondering how do you kind of deploy this to production? Like, is it deployed like as a fast API endpoint, or do you kind of use model servers behind the hood? And what are some of the constraints, challenges, optimizations that you all have had to do in the process to be able to handle, a really good scale?
Yeah, so the model, like it's deployed in again like a Kubernetes cluster. Um, like we use gRPC, so like we don't like in this case like we kind of decided to just using just fast API. I like just having this request sent as JSON because I feel like it's more flexible. But it's also true that like gRPC is more restricted. It's like I feel like it's safer, and then efficiency speaking it's faster. So we kind of agree on like just using a gRPC interface like to do send the request. And then yeah, like the model is deployed in like the Kubernetes cluster, which can be auto scaled. Yeah, so it works most of the time. So that's pretty much how.
Katrina, like one question with regards to given these models are running in production, how does the model monitoring pipeline look like for you all? What frameworks do you all use for drift, metrics that you all use for tracking model performance, and how have you all implemented that?
Yeah, so we do have like a very kind of, I think it's kind of enough, like at least for our use cases. We do have like a kind of, we like during training, we log the offline metrics, and then we set up dashboards to like track that. And then like during data processing, we also have set up like just like right to like some kind of table, like just so that we can monitor the online metrics as well. Like so like offline metrics is like accuracy, like F1, like ROC, those kind of thing. And then online metrics is usually like acceptance rate for us. So we also have another dashboard for online metrics as well. And then like for just like to detect feature drift and stuff, like we like it's actually my previous manager that write this. He write like our own framework of like doing anomaly detection on features,
Okay.
and then on like the yeah a lot of stuff. So we utilize that framework to do anomaly detection to detect feature drift. Although I would say because we do train our model like every day in Airflow, and we kind of deploy the model at least once a week. So we actually don't worry about feature drift a lot because it's like
Okay.
just deployed pretty regularly.
Oh, that is a very interesting thing. Like you bring up, like that's quite good. Like if you are able to retrain your models quite often, then probably the drift really doesn't
Yeah,
matter because
yeah, it's really
that's
not a problem for us at the moment.
how have you automated this retraining pipelines? Like, or is it like manually triggered every week? Like, or have you done something to kind of retrain automatically or something?
Yeah, the retraining is like we kind of probably like it's pretty automated. So like the airflow is just like a daily kind of schedule. We set it up, and then because I was from Tableau, I know like how complicated you can do stuff in Tableau, but like the framework they set up, it's very easy to use. It's not super complicated, but it can kind of do what we wanted. We just wanted to track the metrics, or we wanted to compare some like basic data. We really don't want to do really complicated stuff. So that's why we kind of just utilizing their framework just to set up dashboard, and then the dashboard can also automatically update it whenever there's a new data, and then we just select the date range. It can just query from the table and then just have a refreshed dashboard. So it's like pretty much everything is automated. And even when we are adding new use cases, we don't need to do any much changes. Like the online metrics will be automatically updated with the new use case, with the data from the new use case as well. So yeah, it's pretty much automatic.
Got it. That's great. And what metrics do you all use to measure like the business impact of the recommend API and would love to hear a little bit on that.
Yeah, because a lot of our use cases is really like user clicked on it or user accepted, right? So like like the major metrics that we use to monitor online as well as like just determining like if we wanted to like it from A/B testing, if we wanted to go for which model, it's usually acceptance rate. So that's pretty much the major metrics we use for us.
Got it.
But then if we wanted to but if we're incorporating our like recommend API to different product team, they have different metrics they wanted to track, like joiners, like successful teams, like a lot of like top priority Slack metrics they are tracking as well.
Got it. Understood. Understood. One thing, Katrina, I wanted to touch, like while you have covered the entire ML system from the data processing pipelines to the feature store to the training and deployment monitoring. What has been some of the core principles around which you all have tried to build the stack at Slack, and every time like you all have to change it or evolve it? What are some of the core principles you all try to abide by, say from a developer's perspective, or what are some of the constraints you generally see in the system?
I think for us, it's really like customer privacy. That which it's not really technical stuff, but really like we value like custom privacy a lot, and we are also constrained a lot by it. Like a lot of things we just cannot do because use like customer won't allow us to use the data, like right. So like a lot of like we respect that, but just like it's truly a lot of a restriction. I think that's true for all enterprise softwares.
Right.
It's like different from like P2P, like B2B is like just a bit trickier than just like if you're in Facebook, you can just like use this data, I guess.
How does it impact the architecture in the way you all run the training, like the way the data is stored, and what data can be used to train what model, and uh, what maybe architectural choices you had to take in the overall training architecture or the infrastructure to
Yeah,
be
I
able to
guess.
do this data privacy part.
Yeah, one thing is that yeah, we have to be extremely careful about handling data. So there is like another set of place like the data in the data warehouse. We can kind of store um, some more sensitive data, but then they are all like I think they are like PII. Like there are huge effort in data engineer team as well to like just get rid of like a PII information, or like set up a retention policy so it's like adhere to the general policy. So but we cannot see the data from that secret data warehouse. Like it's called Manitoba. So it's just making us really easy to sometimes, oh, like this model, the training went wrong, like we cannot even see the data. So it's like, it's a bit tricky to debug, I would say. Like if we include a little bit sensitive data, like for example, the spam detection, like it's like it has like emails or like some kind of, it's trained on a little bit sensitive, like those kind of sensitive information. So it's like trained in like, is interacting with like that secret database. So like we don't have much interaction with, and that's probably also why we are not doing, like, it's kind of logistic regression going on there. So we are not doing a lot with it.
Okay, understood. Cool. That's great. Let's jump and switch gears a little bit, and with the LLMs and the Gen AI coming in, you all kind of introduced Slack GPT. Just curious to maybe for the users, what does Slack GPT really mean? What use cases does it empower? And then would love to kind of later on dive into maybe the stack from the LLM perspective.
Yeah, I think one thing, like, kind of like, I think it's like kind of announced, but like in the blog, like in the post. But one thing we wanted to try out first is really just summarization, because user complain about information overload a lot in Slack. Even for me, like, okay, this thread is like 20 messages. I need to follow. I'm just gonna save it and follow up later. Like, but like it's like in a couple of days maybe.
Right.
It's like really hard to follow up with like those long threads, or like when you're back from a vacation, it's like usually takes quite some time to catch up with all the messaging in Slack. So we are really trying out some kind of summarization functionalities utilizing the LLM models. That's first we want to try. Of course, there are like a lot of things that people are exploring or POC in the way. Yeah, I'm also looking for. Oh, it's like still like a bit uncertain, like to me, and I'm also looking forward to like what the product team will come out. I really think it's kind of like Slack as a, like, natural language, a platform for like natural languages, like has like tons of potential.
Awesome. Maybe diving into this question, like as you all built Slack GPT, and surely you all are building more LLMs as well. Want to understand like what has changed from an infra perspective in training these large models compared to the earlier models. What all innovations did you all have to do? How do you kind of optimize for cost in those and so on?
I think, yeah, I also have this like, I kind of reflected on this because I was like watch a video on like what's the role of ML engineers in the era of like these kind of large language models. It is true that you don't need like certain level of expertise to start just doing it. Like product engineers can just set up very easily like those models in SageMaker. It's like 10 lines of code to deploy that model, and then they can try out prompts and they can just start just doing things. They like, it could feel like they don't need us anymore. But yeah, but it's like, but like recently also like kind of started to feel like they do need us, because they set up the first version. It's like, it's okay, like from product side, but what about the quality of the summaries, like how you structure, how you like 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 the engineers, they are like really good, like they are like senior staff, kind of like really great engineers, but they may lack a bit on like exploring stuff. Like how about like I wanted to try this out, that out, like iterate exploration. They may lack this kind of, just like, because I came from like a data scientist background, I'm kind of nature to this. I like to explore the, like a little uncertainty, but they kind of lack it. So in a way, like, so that's why I was like kind of mainly like kind of doing like the prompt tuning thing, like just to make sure like we have the first version, but the output is like pretty terrible. Like it's like if you look closely, the content is okay, but like the how it's formatted is like pretty unreadable. So we wanted to make sure like it's like the output is structured using prompt tuning, and then make it much nicer to read. And then in the later stage, we wanted to have like a more systematic way to evaluate prompts. I know there are a lot of tools coming up. I'm not really impressed by like I saw, I didn't see all of them. I saw like a few of them. Like I feel like right now it's really still a bit uncertain. Like kind of like everyone is talking about how to evaluate, and then but like in a way this kind of model is like the results is pretty subjective. And then there's also talk about you can use like the best model to evaluate the response and stuff, but I feel like people still wanted to subjectively judge these like kind of responses. So how to like build a system to more systematically evaluate if different prompts, enable others to try it out. Like this is kind of a problem like our team wanted to solve, because right now it's like I'm doing things in my notebooks, but then there's a disconnection between like offline and still like online. Like we use like a different language like in the back end, like, and like the data I got is still slightly different. Like yeah, so like the disconnection between offline evaluation and online production, we wanted to solve that. Yeah, and also just make sure like other product engineers and then PMs can also try out prompts like in a more systematic way, not just to merge it and then let's click this magic wand and see what's going to happen. Those kind of, yeah. So that's our role. And then at the moment, for sure, I can see it more clearly. Like when like this kind of LLM came out, I was also wondering what's my role as an engineer. Everyone can do it, but it's still not true. Like we are still needed now to make it better. Yeah.
Understood. And maybe I would love to hear this. Like, what do you think, and your take on the future of prompt engineering? You touched base on a little bit, but where do you think it will go, and what will be the interface that will be needed for data scientists and ML engineers to actually, rapidly experiment and across different models? Yeah.
Yeah, the prompt engineer is like, it's very important for sure. Like it can make the response go from garbage to like really good responses, I think. But it's like also like very tricky and uncertain. I was trying, oh, like let's add this word, or let's change. Like it's like there are like some kind of like lessons online to tell you how to do prompt engineer, but it's still like a very like explorative, like uncertain like phase where you are gonna, okay, I'm gonna change this word and see what's gonna happen. Like this, I'm gonna move this sentence to the like over here. Like yeah, it's I don't think it's gonna, I hope it's not gonna be like this in the future, but I'm also just not sure what's gonna happen. Yeah, like yeah, honestly, like the future is hard to tell, but yeah, I definitely hope
And
it's not at the beginning, but it kind of becomes okay, a bit boring after a while. Yeah.
Understood. Great. Last question for you. Like, what are the changes you're seeing with these LLMs coming in, and how do you kind of stay updated with these new developments that are happening in this space?
Yeah, definitely. Like I would say I'm not like super. I'm not that kind of person that like read every paper that came out for sure. Like I care more about practical usage. Definitely, Twitter is like something like I kind of follow. Like just like there are like a lot of new information. Like if you wanted to keep up to date, follow the important persons on Twitter is definitely like the most efficient way to learn about this. I also learn about like my colleagues share news like Llama 2 is released and it's available in SageMaker. Those kind of things, like colleagues also share them. So yeah, I keep mostly updated. I care more about what's actually like the use case that came out. I want to see what is there anything that's actually going to change my life. Those kind of thing I care more about. So I'm a bit lacking on reading papers and stuff, I would say.
Yeah. So, but I feel like I'm updated enough to to work. To yeah.
Great. I think thanks a lot, Katrina, for the time. It was a great conversation. Knowing about the recommend API and the use cases and the overall stack of ML at Stack. Appreciate you taking time for this chat, and all the best for the new LLMs you all are trying, and look forward to kind of having you again.
Yeah. Yeah. Thank you. Yeah.